Hello everyone. In this video, we will do an example which involves making a new random variable out of all random variables and computing their expected value or variance using the formulas we have. So let's see what is the example. The example actually we have worked on before. A sales representative have observed that the probability of making a sale is 1/4 for each customer contact. It means that out of every 4 customers that he contacts, he can sell uh, one product. Um, okay, but the question is not about how many, the question is about how much money he earns. He earns a salary of $500 per week. So constant $500 every week, no matter how many sales he makes, is going to be given to him. Plus a commission of $50 per sales that he makes out of 12 calls that he makes every week. So he calls 12 customers every week, and for every single one of them that he actually sells the product, for every one he gets an extra $50. Now the questions, the example asks to find first, what is the expected, what is the average income of this representative per week? And what is the variance of his income per week? Well, okay. So first thing to note that then the number of sales per week for this representative is a binomial random variable. You should see that, well, he's doing 12. These are kind of independent. Doesn't matter if the previous one bought it or not. So he's doing 12 of these experiments, and the chance of winning here, it means selling something, is 1/4. So that the number of the successes is counted by the random variable B12 1/4, a binomial random variable. But this is number of random sales. What we are interested in is the income for this guy. Well, what we know that he will get $500 per week, no matter how many sales he makes. But we also know that for every single sale, he will get an extra $50. Remember, this is counting the number of sales he is able to do every week. So each one multiplied by 50, that would be the commission part. This is the salary part. Salary, and this is a commission. So we are trying then, for one, we are trying to find what is expected value, the average income, or average of 50 B12 1/4 plus 500. You should remember this all the time. The expected value works nicely with linear operation, adding and multiplying by constant. They are friends. So let me just write here as recall that E of AX plus B is E of X plus B. So in this specific case, we will get 50 E of B 12 1 over 4 plus 500. Okay, now it is written in terms of binomial 12 for 1 over 4, but if you remember, for binomial you don't need to do strange computation. For binomial, the e of b n p is equal to n times p. So here, oh, sorry, here this is 50. E of b 12 1 over 4 is 12 times 1 over 4 plus 500, and then this is 3 times 50. This is 150 plus 500. This is 650. So his average income from this company is $650 per week. Well, how about the variance? So variance of income is 50b12 1 over 4 plus 500. What you should remember is that the variance is a little bit strange with the linear things. Variance of ax plus b. Well, if you add a constant, it's not going to change the variance, but the constant multiple will come out as a constant multiple, but not itself, a square of that. So it kills b, but the constant comes up double. So here it will have 500 squared v of b 12 1 over 4, and this is 2500. Well, this is another fact that you have to remember. Let me just again put another box here and write it. V of a binomial random variable n, b, and p is n p1 minus p. So in this case, we will have n p1 minus p. So this is times, you see this will be 3 over 4, and then this will cancel with that, it will be 3, so 9 over 4. Well, this is a number we can simplify, but let's just leave it as it is. So that's the variance of the income of that representative.